Hello students, good morning and welcome to our lesson today in mathematics. Today we are looking at Form 3 mathematics and we are discussing the topic surds. First of all, before we go into surds, let me highlight what is key here so that when you are revising on surds, what do you focus on? So those will be our key areas. One of the main area that you must look at is what we call simplification of surds. Simplification of surds. How do you simplify surds? That is the first area of concern. Number two, when you are revising surds, be able to know what is called rationalization. Rationalization of the denominator. Rationalization of the denominator. These are the two areas that this topic will require you to understand so well if you want to get any mark from the topic. But before we look at these main areas, we have to set the foundation and know what is required before we get the simplification of surds. So let's look at these areas. First of all, students, you need to know what's a surd. What is a surd? Before we get into that, let's consider these numbers. Consider the following numbers. And then I will ask if anybody knows what is root 2. What is the value for root 2? Yes, you'll tell me that this is it will give you a number which is decimal. This is a decimal number to give a decimal value that does not end. That is, does not come to an end. And the values do not repeat. They do not repeat. So therefore, it is not a recurring value. Again, if we consider the same as root 5, it will be the same situation for root 2. If you consider root 7, it will give you the same case. Again, if we have now, let's take of what we call root 3, a cube root of a number 4. Same solution, a decimal number that has that values do not repeat and does not come to an end. If you have the fourth root of a number 5, same situation as it is with root 2. These numbers are what we are referring to as surds. A surd is simply a decimal number that gives a root that has a decimal value which does not come to an end and the values or digits do not repeat in the number. That is what we call a surd. And surds are what we call irrational. Numbers. So dealing with surds, we also mention them as to be what we call irrational numbers. And numbers like, if we now consider this one, for example, the square root of 4. There is an exact value for the square root of 4, which is 2. If I consider the root of 9, the solution is 3. Again, I can consider just real numbers as 5 without the root sign. These real numbers are what you call now rational numbers. These will now become rational numbers. So when there is an existence of a root, then we refer to them as the irrational numbers. But now, when there is an exact solution that can be obtained, then we call them rational numbers. And so in the simplest terms, a surd is simply a root that has no its exact value, or simply numbers that have no exact roots. So we can now conclude and say that surds are numbers that have no exact root And in this case, we're talking about it can either be cube roots, or it could be square roots, or it could be fourth roots, or fifth roots, depending with the situation that you are dealing with. And so in general, a surd is a number, expressed as, so we have this, that. So if you are reading this value, if you read this surd, this one is simply read as, the nth root of A. So we read that as the nth root of A. And so what does n here stand for? In this case, where n represents what we call the order of the surd. That is the order of the surd. And A is our number. Again, students, I want you to note that what I've written is nth root of A. This one is not the same as n root A. This is nth root of A, but this is n times root A. They are very different. So we are emphasizing that it has to be nth root of A so that you can be able to tell that n becomes the order of the surd and A becomes the number. And that takes us now to the next part, that once we've known what's a surd, then do we know how to identify the order of surds? The order of surds. It is very simple. If we can have, for example, here the surd, and in this case I have the order. All square roots are to order 2. Why? For example, if I have the square root of 3, square root of 3 simply means 3 power a half. And so this 2 is what defines the order. So this is order 2. If I have cube root of a number 4, then this is the same as saying 4 power a third. And so the 3 defines the order. So this is order 3. If we go to the fourth root of a number 10, this is the same as saying 10 power 1 over 4, and 4 defines the order. So we have order 4. Again, fifth root of 12. This is 12 to the power 1 over 5, which gives us order 5. And that's why we are saying, in general cases, if you have a surd of n root of A, then n defines the order of that surd. But in most cases, what we shall be dealing with in surds in this topic, we concentrate mostly on the surds that are of order 2. So when looking at Form 3 surds, we will look at surds that are of order 2 to analyze these 2 areas that we've listed as our main areas of concern. So with that, students, therefore, it is simple to look at exactly where the examiner will bring questions from, because this only gives us the foundation of what we need to do. But now, when questions are tested now, we focus on these 2 areas. Either you'll be given a question to simplify a surd, or you'll be given a question to rationalize the denominator. So how do we work out the simplification of surds? How do we work out simplification of surds? Simply, how to simplify a surd. Simplification is simply a process of reducing a term from a complex to a simple form. When you reduce the terms from complex to simple form, then we refer to that as simplification. So surds can be complex in a way, and so we need to simplify the surds. So what do you do when you're simplifying the surds? It is very simple. The first thing is look at the number under the root sign and identify two numbers. You simply find two numbers. Identify two numbers whose product will give the number under the root sign. And one of the numbers should be a greater number, with exact root. Then once you have that, then you write the surd in the form n root a. Let's do an example. If you are told to simplify, and you are simplifying a surd that is root 48. We are told to simplify root 48. So using factors in form 1, identify the factors of 48 to get the two numbers whose product is 48. And one of those numbers must be able to give us the exact root. You'll easily find that if you have 48, the factors of 48, 2, this is 24. Again, 2, this is 12. 2, this is 6. 2, this is 3. So it means if I have 2 times 2, that is 4, times 2, that is 8, times 2, that is 16, then 16 times 3 will give us 48. So I will rewrite this root 48 to be equal to root 16 times 3. Then we split this to have root 16 times root 3. And we all know that root 16 is a rational number which has its exact value. The square root of 16 is 4. So it means this is 4 times root 3. So this then gives us 4 root 3. And this is the form that we are saying here, n root a, where now n in this case becomes 4 and a is 3. Again, remember, this is not the same as roots. This is not the same as saying 4th root of 3. It is very different. It is simply 4 times the root of 3. That is one way. Another example, it could be we are told to simplify the square root of 32, which has the same factors just as 48. 32 will now be, root 32 will be equal to square root of 16 times 2, and this becomes the root of 16 times the root of 2. So again, the square root of 16 is 4 times 2, so that becomes 4 root 2. That becomes 4 root 2. If we have root 128, if we are told to simplify root 128, the factors of 128 will have this as 2 to give us 64. And there is exact square root of 64. So we'll have 64 times 2. Split this to have root 64 times root 2. The square root of 64 is 8, and so we have 8 root 2 as our solution. So that is how we carry out simplification of surds, to reduce them from being complex surds to simple surds. And you'll find in most cases when you are simplifying surds, you'll find that you'll always get the number under the root sign will be a prime number. The number under the root sign will be a prime number. But the procedure is quite simple. Identify two numbers whose product is the number under the root sign, and one of those numbers should have the exact roots. Again, after simplification, it is important to understand what we call operation on surds. Operation on surds. And anytime in mathematics we talk of operation, then we are talking about these four main operations, that is addition, subtraction, multiplication, and division. When you are working out addition of surds, what do you look at? But there is a rule that we must always consider in addition and subtraction. In addition and subtraction of surds, we say for two surds to be added or subtracted, they must be able to be in line with these two principles. Number one, they must be of the same order. They must be of the same order. The two surds must be of the same order. And we've seen how to identify an order of a surd. Number two, the number under the root sign. The number under the root sign. Under the root sign must be the same. Those are the two conditions that must be met before you look at, you confirm whether the two surds are compatible in terms of addition or subtraction, or they are not. And so in this case, if, for example, we are given this situation, you are told to evaluate 2 root 3 plus root 3. 2 root 3 plus root 3. If you have this case here, to work out, it is simple. Why? Because all these two surds are of order 2. Because this is root 3 and this is root 3, that is order 2. Again, the number under the root sign is 3 and 3, meaning that these two surds have been able to follow this principle for addition of surds. So how do you work it out? What you do is simply add the coefficients. Add the coefficients of the surds and retain the surd in the solution. Only work out the coefficients of the surds. The coefficients here, we are talking about 2 root 3. So that's the coefficient. And then this is root 3. So we have 1 root 3. So I will say this is 2 plus 1, and then retain this root sign, root 3. So I have a solution of 3 root 3. That is the solution. So in the addition of surds, Work out the coefficients and then retain the surd in the final solution. Assuming we had this case, 1 over 3 root 7 plus 1 over 2 root 7. All these are to order 2, and the numbers under the root sign are the same. So it is possible to add. Again, what do? Look at the coefficients and sum them. So you have 1 over 3 plus 1 over 2, and retain the surd. So we have root 7 in our solution. If we work out these fractions, a half plus a third, so that will be 5. That will be 5 over 6 root 7. Because the LCM is 6. 3 into 6, that is 2 times. Then 2 into 6, that is 3 times. So 3 plus 2, that is 5 root 6 as our solution. Number C, we can have a case of negative 5 root 11. We minus 2 root 11. Now subtraction. The same case, look at the two coefficients. That is negative 5 minus 2, and then retain the roots, the surd. So this is negative 7 root 11 as our solution. So that is how we add or we subtract surds. That these surds must be of the same order, and number 2, the number under the root sign must be the same. Next thing, after addition and subtraction, we must do now multiplication. We must do now multiplication and division of surds. Now, unlike in addition, where we are saying they must be of the same order, and then the number under the root sign must be the same, this principle does not apply in totality to multiplication and division. So when you want to add or want to multiply surds, what must you consider? So you say two surds can be multiplied or divided if they are of the same order. If they are of the same order, I will say the number under the root sign must not be the same. So the case for the number under the root sign being the same must only be observed when you are doing addition and subtraction. But when it comes to multiplication and division, the number under the root sign might be different. But then we have to ensure they are of the same order for us to be able to achieve the solution or to achieve the compatibility of the surds in either multiplication or division. So to illustrate this, let's use this example. So you are told to evaluate. We have 3 root 35. Then we divide by 2 root 7. When we are dividing this case, we are saying, yes, they have to be of the same order, That's why you have this is order 2. But the numbers under the root sign could be different. So what you do is, the procedure is work out the coefficients first. That is simply divide the coefficients and the numbers under the root sign. Numbers under the root sign separately. That is to mean, look at the coefficient of root 35 in this case is 3. So I will have 3. I divide by the coefficient here, which is 2. And then I have the root, take 35 and divide it by 7. If you do this, what you have here is 1.5. Root 35 divided by 7 is 5. So this is our solution. 1.5 root 5, which can simply be written as 3 over 2 root 5, or someone will still write it as 1.5 root 5, depending with the situation or what you've been asked to write. So you'll have divided the two surds simply by looking at what are the coefficients, and then once you've looked at what are the coefficients, you look at what are the numbers under the root sign. Again, assuming we have this case, 5 root 6, and then we have times 2 root 3. 5 root 6 times 2 root 3. In this case, because this is the multiplication, again, multiply the coefficients of surds and the numbers under the root sign. And the numbers under the root sign, that is separately. So what's the coefficient? It's 5. So you take 5 times, the coefficient here is 2. Then root 6 times, and again here we have 3. So this is 10 root 18. 18 can be simplified further because it's a composite number. If it's a composite number, what you do, try to simplify. And we've done the simplification of surds. So for 18, it simply means 18 is 2 here is 9. And we can get the exact square root of 9. So I replace it here and say 10 root 2 times 9. This means 10 root 2, then times root 9. What's the square root of 9? 3. 3 times 10, 30 root 2. That becomes the final solution. So you can find a situation whereby you work out the surds and you come to a point where you have to simplify the surds. It is possible because we've already discussed how to simplify the surds. So those are areas that we need to look at. But there is one very important area in surds, which is called rationalization of the denominator. Rationalization of the denominator. It's a very short topic, but quite important, especially when looking at rationalization. So we have rationalization of the denominator. Rationalization of the denominator. Now, what is rationalization? What is rationalization? Rationalization is simply the process of eliminating a surd, the process of eliminating a surd from the denominator is what we call rationalization. So we are going to be given we are going to be given a surd where, a situation whereby there is a surd on the denominator, and you are told to rationalize. What it means is simply take out the surd from the denominator. So this is simply a process of eliminating a surd from the denominator. To eliminate here, it's simply to remove. And we are not going just to remove it without a process. There is a process that we need to do in eliminating the surd from the denominator. And the process is very simple. First of all, you have to know what's a conjugate. We have to get the conjugate of the denominator. Simply procedure. Simply multiply both the numerator and the denominator by the conjugate of the denominator. That is the step that we follow. If you want to rationalize the denominator, what you do is identify what's the conjugate of the denominator and multiply both the numerator and the denominator by that conjugate. So what's the conjugate? Or how do you get the conjugate? When you are getting the conjugate, you simply change the sign of the two surds, or the sign that is connecting the two surds. You change the sign. To get the conjugate, simply reverse the sign between the surds. You reverse the sign between the surds. For instance, this could be a surd, and this is our conjugate. If I have, for example, root 2 plus root 3, these two surds are connected by addition. To conjugate this surd, I simply change this sign, now becomes minus. So it is root 2 less root 3. That is the conjugate. If I have another surd, let's say root 5 less root 7. To find the conjugate of this surd, we will have root 5 plus root 7. You simply change the sign. So when you are looking at the conjugate of surds, simply change the sign. Change the sign between the two surds. Then you will have obtained what we call the conjugate. So in cases for now rationalization, how will the question be set in this part? You'll be told to rationalize. Rationalize. And then you're given this case 3 over root 5 plus root 2. 3 plus, that is over root 5 plus root 2. So here, our denominator is root 5 plus root 2. We need to know what's the conjugate. Our solution will be 3 over root 5 plus root 2. The conjugate of this denominator is root 5 minus root 2. So you multiply on both sides. And at that point, do not be a victim of cancelling here. Because if you cancel, you will go back to the question. So ensure you work out the numerator and the denominator differently. So we have the numerator is 3 into root 5 less root 2. This one will be 3 root 5 less 3 root 2. Our denominator will now be root 5 plus root 2, root 5 less root 2. Now, this can be worked out by expansion in the long method, or you simply apply what we call the identities, quadratic identities. And I believe we know what are the quadratic identities. You apply the quadratic identity. That should be the third quadratic identity. And what's the third quadratic identity? A number A, add a number B, multiply by number A less than number B, it should be A squared less B squared. What we call the difference of two squares. The difference of two squares. That is the third quadratic identity taught in Form 2. So what you do is, for this case, because these terms are the same numbers, the only difference is the sign. Do not waste time multiplying every term in the first bracket by every term in the second bracket, even though it will give you the correct answer. Simply apply this identity. So if I apply this identity, it's mainly going to be root 5 squared less root 2 squared. And by now, as Form 3, you understand when you have root 5 squared, that is 25, root 25, which is 5. So you simply take 5 less 2, and the answer is 3. So it means the denominator gives us 3. Now, divide it and say, this will become 3 root 5, 3 root 2 over 3. So this gives us root 5 less root 2. We shall have rationalized our denominator. And you can see in our final case, our denominator is 1, which is not a surd. And that is the essence of rationalization. So when you're told to rationalize, the surd, simply eliminate the surd from the denominator by a very simple process. Multiply both the numerator and the denominator by the conjugate of the denominator. Now, as we come to conclude our lesson, let's look at questions. Questions that you've been able to send. And so, I don't know if there are any questions. Okay. Okay. Now we have these are the things that have been questions that have been asked so far. Did you say that surds are numbers with exact roots? No. Simple numbers with no exact roots, and that's why we call them irrational numbers. From Nakuru, someone is requesting for indices. We have Weekly from Kisii. Thank you. Hello, teacher. In multiplying and division of surds, if the number under the root sign are same, do you work it out the same way? You'll work out the same way. Just multiply the numbers under the root sign, or divide the numbers under the root sign, and then work out also what is the coefficients of the surds. So what we only meant is that it is not a must that the number under the root sign will be the same. It could be different. Again, we have someone is saying that I didn't understand that for division. Division, we said if you are dividing, for those who are looking for clarity in division, when you are dividing surds, assuming that you have this case, you have a surd n root a divided by m root b. Then what you are saying is work out the coefficients, that is n over m, and then have a over b. For multiplication, what we are now saying is we have n root a times m root b, then what you'll have is n times m, and then have root a times b. That is what you follow in division and multiplication. Someone has sent another question here. We have 1 over, if 1 over 3 less root 5 less 2 plus 2 root 5 over 3 plus root 5 is a plus b root c. We find the values of a, b, and c. Now, we can work out this. In this case, we have 1 over 3 less root 5 minus 2 plus 2 root 5 over 3 plus root 5. If you look at these two, the LCM is the product of these two. That is 3 less root 5, 3 add root 5. 3 less root 5 into this is 3 add root 5, then minus this into this will give us 3 less root 5 into, now we have 2 plus 2 root 5. So I work out the numerator so that I have 3 plus root 5 less 3 less root 5 times 2 plus 2 root 5. By expansion, at this point, we shall have 3 by 2, that is 6, less 6 root 5, less 2 root 5, then you add 2 root 25. Then less 3 plus root 5. So that I have 3 plus root 5 minus, this is 5 times 2, that is 10. So 6 minus 10, that gives us minus 4. Then we have minus 6 root 5 minus 2 root 5. That should be negative 8 root 5. If you spread this negative into the brackets, so you'll have 3 plus root 5, then plus 4 plus 8 root 5. Collect like terms. 3 plus 4, that is 7. Root 5 plus 8 root 5, that is 9 root 5. That is our numerator. For our denominator will be 3 less root 5, 3 add root 5. The quadratic identities, this becomes 9 less 5, which is 4. So it means, therefore, that the denominator gives us 4, and the numerator gives us 7 plus 9 root 5. So we'll then have 7 plus 9 root 5 over 4, and this will give us 1 and 3 over 4 plus 2 and 1 over 4 root 5. So that will be our solution. And so it means that therefore our A is 1 plus 1 3/4, our B is 2 1/4, and our C is 5. Someone is asking a remainder about the conjugate. When you're getting the conjugate of a surd, we've said the conjugate of surds is simply done by reversing the sign between the two surds. You simply reverse the sign between the two surds. If, for example, we have root 6, that is plus root 7, then this becomes root 6 less root 7. We are insisting on the sign between the surds, not the sign of each surd. Finally, we repeat about rationalization of surds. We said if you want to rationalize the sides, it is very simple. Simply multiply both the numerator and the denominator of the surds by the conjugate of the surds. So that is what we can be able to do for today. I hope you've learned something from surds, and that will be good for your practice at home.